Find the average value of f on 0 to 2. Remember that the average value function is 1 divided by b minus a times the integral from a to b of f of x dx. In this case, we have 1 divided by 2 minus 0, integral 0 to 2, x plus 1 cubed dx. Simplifying this, we get 1/2 times, we need to integrate that, and really to integrate that we'll use a u sub. You may be able to see this one without the u sub, but let's show the work. U will be x plus 1. Du will be 1 dx, or just dx. So we now have the integral of u cubed du. And the new limits of integration, when we plug in 0 to u, we get 1. And when we plug in 2, we get 3. So now if we integrate this function, we get 1/4 u to the 4th. And we are evaluating from 1 to 3. We have now 1/8. If we plug in 3 to the 4th, minus plug in 1 to the 4th, that is 1/8 times 3 to the 4th is 81. 1 to the 4th is 1, so 81 minus 1 is 80. We'll get 10. In part B, we're using the mean value theorem. We want to find c in the given interval such that the average value is equal to f of c. So the average value we just found to be 10. And f of c, recall that f of x is x plus 1 cubed. So f of c is c plus 1 cubed. Now to solve for c, we'll take the cubed root of both sides. Cubed root of 10 is equal to c plus 1. Then subtract 1 on both sides. Cube root of 10 minus 1 is equal to c. So here's our c value. And if we wanted to approximate that c value is roughly 1.154. You can verify that in your calculator. In part C, we want to sketch the graph of f and a rectangular whose base is the given interval and whose area is the same as the area under the graph of f. First of all, let's recall what f is. That was x plus 1 cubed. So we know what x cubed looks like, and if you remember your transformations, x plus 1 is just a shift to the left 1 unit. It's going to come down here to -1. And the interval that we're focusing on is 0 to 2. So let's plot some points. I'm going to change the y-axis. The y-axis, the scale will be a little bit different. Let's see, if we plug in 0, we'll get 1 cubed, which is 1. And if we plug in 2, 2 plus 1 is 3. 3 cubed is 27. So let's come up here to 30. And we know that one of the values we're concerned about is 10, so let's increment in units of 10. So if we plug in 0, we'll get 1. If we plug in 1, 2 cubed is 8. And if we plug in 2, 2 plus 1 is 3. 3 cubed is 27. So the graph will look something like this. And we're focusing on 0 to 2. Let's look at the area under this curve first. So if we're integrating From earlier, we did a u substitution. We did 1 to 3 u cubed du. That will be 1/4 u to the 4th from 1 to 3. That is 1/4 times 3 to the 4th minus 1 to the 4th. 1/4 times 3 to the 4th is 81. 81 minus 1 is 80. So we get 20 for the area under the curve, that blue area. Should have done that in blue ink. And we're also looking at the rectangle whose base is the given interval. Base is the given interval, and we're going up to 10. That was our average value. And notice what the area of the rectangle is. That green rectangle, 10 times 2, 20. This point where the graph and the horizontal line average value of 10, the point where that intersects is at C, which we found to be roughly 1.154, or more accurately, cubed root of 10 minus 1.